Hi, I'm Dr. Padilla. Welcome back to our exploration into scales with Vega-Lite. We have been working through some of the aspects of customizing scales, and we have so far made it to this visualization here. What have we learned? We've learned some techniques, but we ended up with a visualization that is not that useful. It's really not revealing any major insights. So I wanted to do a video where I bring everything together and I show you some of the techniques I would use to actually gain true insights about this particular data set here, which is very, very fascinating. So right out of the gate, there are just so many dots overplotted on one another that one of the first things that comes to mind for me is go ahead and separating out these different character types. Now, the way that we would do that is to add a row. So we're going to add a row and the field is going to be nominal, and that we'll actually just copy this whole part over here. So we'll add a row for, let's actually do the character types. Okay. So when we run that bit, now the data is broken out by the individual character types. And we can see the characters that are bad, good, neutral, and reformed, which is now in itself a little bit more useful. We can start to look at this and gain some more insights. For example, it wasn't ever really clear what was going on with these reformed criminals. They appear to just have a few that were male and one that was female. Okay, interesting. We can also just focus in on the bad characters and look at the general distribution of those. Obviously, the most being male, female. This agender has a great deal of these bad characters, etc. Looking at good characters, even though, there's certainly more male characters overall, there still feels like a similar proportion of male and female. So as we're going through this, one thing that comes to mind is this is useful. You can explore, you can look at individual data set, you can look at individual values, which is useful, but you might want to know the proportion because there's very different counts of totals. It'd be useful to know of the proportion of male characters, how many were good, bad, etc. So that's what we'll do now. And what I'm going to do for our proportional visualization is I'm going to use a stacked bar chart. That's going to be my goal here. So I'm going to change this to bars, and then I'm going to remove the row. So just by those two changes, we're sort of getting a sense of the proportion. Notice because I have this tooltip as I'm rolling over these, you're seeing the individual names because the data is literally being stacked up on themselves. So we'll want to change this and create a sum or a total for these different bins. And that's pretty easy to do. We can go ahead and add an aggregate and include the sum. And then let's go ahead and remove this tooltip. Okay, so now we have these proportions and this opacity is not serving us either. So let's make that all the same opacity. So now that we have these sums, this is useful. We can start to see these patterns in the different groups. Again, very hard to see these small values. This might be a case if you're using your own visual analytics process and not communicating to the general public to zoom up or clip the data for just these values here. So we could simply go ahead and add a scale, clamp true, and set the specific domain. And here what we've done is really just zooming up on those lower values. I set it to 100, but maybe let's more like 800 or 9. Okay, I'm looking to try to get these agender characters. Okay, so what I'm starting to see now is that for the agender characters, most of them are neutral. Interesting. With some that are bad, some that are good. The female characters, remember, it extends all the way off. Don't think that they're all bad. Same for the male characters. The data is extending and I've clamped it out. I'm just looking at these lower values. For the gender fluid, most are neutral. Also fascinating. The genderless, this is sort of interesting where they seem to have a higher comparable proportion between bad and good characters. And then for this transgender character, there appears to be only one, and that character is bad. Okay, so that's useful. Again, we're not seeing this proper comparison, so I would never show people this visualization. This is just for me exploring the data. So what I'd like to do now is to actually visualize the proportion of this character distribution for the set of each group. I'm going to copy over some code that I previously made to do this. You don't have to type this out. This is really just to show you this visual analytics process. If you do want to type it out, then go ahead and pause the video once I copy it over. So what we're actually going to do is in this transform, we're going to add a few more transformations. We're going to do an aggregation where we are going to create an operation. We're going to do a count. We're going to call it count so we can reference it later. We're going to group by sex and align. And then we have this window here, which allows us to do the calculation across various fields. So we're going to do this sum across these different groups. And this allows us to continue doing that summation across the entire data set. That's what this is ultimately leading to. And the actual calculation we're going to do is we're going to specify the proportion, where we're going to take the data count over the total, obviously making a proportion, and we're going to save it as the proportion. Okay. If you want a slower breakdown of transforms, I recommend watching our video on transforms and calculations. The other thing I'm going to do is change this y-axis. Rather than having it be appearances, we want it to relate to this calculation that we've just created up here. So that's what this code does. We're specifying the proportion as a quantitative value, and we're just writing out the title for it. Okay, so now what we have going on is we're seeing the proportion of appearances by each gender, which is very fascinating. Again, showing us that the transgender character, all of the one individual was a bad character. So I think this is a more fair relative comparison that accounts for the total number of people in each group. Now, this is an excellent opportunity for us to sort this in some type of meaningful way. I don't know what a proper sort of the gender is, but what I would like to do as someone who's communicating the data would be to sort based on the proportion of bad characters. So we can highlight which group has more bad character representation. Now, there's several ways to do this. The most simple in this case, because we do have these several levels of calculation, is to hard code the order, which I showed you how to do in a previous video. And what that looks like would be at the end of this y value, specifying a sort where we individually specify the order that we want the categorical values to be in. So here's what that looks like. And I've sorted it based on the proportion of bad characters. So what this visualization is now highlighting to me is that if you're focusing on the bad characters, transgender characters are more likely to be bad, then followed by genderless, and then male, agender, female, and then none for the fluid characters. And I think this makes an important point that the way that you start visualizing your data really pertains to the message that you're trying to convey. In this data set, I think it is very interesting to look at bad character representation. There's work in psychology that indicates that representation influences how we feel about ourselves. So if you only see representation in comics or in other media of negative attributes for people with whom you identify, you will have more negative feelings about yourself. We're looking at this in terms of gender, and we're certainly seeing some serious representation issues for individuals who are transgender. But this data set ends at 2014. So it might be updated now. We might have some better representation, possibly. That would be a really good project for someone to analyze. Now, I do want to say in this data set, there are additional values that we haven't looked at, including eye color and hair color. So I would encourage you to take what we've done here and see how the eye color and hair color that you have is represented in this data set. Are people with your eye color always considered good or bad? If so, it might impact your feelings about your own attributes, unfortunately, and it really highlights how important representation is. And we found this in this simple data set. And the last thing, as promised, is I wanted to show you an example of scales that update automatically. In Vega-Lite, the true power, as we've discussed, is interactivity. And so we've only looked at these fixed static scales, and you can create a interactive interface that will update based on input parameters from your users. Now, what I've done here is I've taken these data sets and I'm using our favorite small multiples approach, and I've broken this out by DC and Marvel. And then we have all of the genders here, color encoding with little tooltips so you can see which gender is which. The green is obviously male characters. And this alone is a pretty useful thing to look at if we're looking at the change over time for DC versus Marvel. For example, Marvel had this huge spike in bad characters early on, probably in part because they needed a bunch of bad characters to kill off. So there's certainly an influx of these bad characters and, not the same proportion of good characters. And you can see, the difference between men and women, that there's a much larger proportion of men, kind of changes over time, grows a little bit, but for the most part, if we're looking at bad characters, that's staying pretty flat, and increase a bit for female characters. All very interesting. My point here is that you can use some of the additional interactivity that we talked about in previous lectures to update your scale dynamically. Here's what the code would look like for that. And again, it's going to be too complicated to go into all of the details, but you want to take a look at that transform video and reflect on how you could update these scales based on input information. In this example, what I have going on here is you can select the different gender. So I can change this to female and notice it automatically updated the Y scale, and change it to male, automatically updating the scale. And you can zoom in and out, obviously. So it allows you to investigate different aspects of the data, which is pretty great. We can look at maybe genderless characters. The only franchise that has genderless characters is DC, and we're really only seeing 2 characters in the 2000s, which is interesting. Taking a look at agender characters, we're seeing just for Marvel, and we're seeing some in the 70s, some later on, etc. I hope you found this example interesting of how you might create a axis scale that updates based on the data that you want to visualize. That will really help you kind of zero in on the smaller values when you want to show that, or scale back out to the larger values. Overall, I think that scales are one of the many useful tools, and I hope this tutorial showed you how to utilize all of these elements together to reveal some meaningful insights in your data.